Ever wondered how your smartphone recognizes your voice or how Google translates languages instantly? The magic behind these technologies is deep learning and artificial intelligence. To unravel this enigma, let's start by understanding what these terms mean. Artificial intelligence, or AI, is a broad concept that refers to machines designed to act intelligently. It's like the umbrella term under which various subsets fall, and one of these subsets is deep learning. Now imagine artificial intelligence as a human brain. Just as our brain uses neurons to process information, AI uses algorithms to mimic human intelligence. Deep learning, on the other hand, takes this a step further. It's a subfield of AI that uses artificial neural networks to mimic the functioning of our brain. It employs a layered architecture of algorithms called deep neural networks to learn hierarchical representations of data. Think of it as a student who doesn't just memorize facts but understands the underlying concepts and applies them to solve complex problems. The magic of deep learning lies in its ability to automatically learn features from large and complex datasets. From recognizing your face in a crowd to translating languages in real time, deep learning is the wizard that powers these remarkable feats. But how are these technologies transforming our world? Well, they're making our devices smarter and enhancing their capabilities. Your smartphone can recognize your voice, your car can park itself, and your home devices can adjust their operations based on your preferences, all thanks to AI and deep learning. So, in essence, AI and deep learning are the wizards behind the curtain, making our devices smarter and our lives easier. Now, let's dive deeper into the world of deep learning. It's not as complex as it sounds, promise. Picture this. You're trying to teach a toddler to recognize a cat. You'll probably show them pictures of various cats, pointing out the common features: whiskers, a tail, pointy ears. Over time, the toddler starts to understand what makes a cat a cat. This is essentially how deep learning works. It's like a virtual toddler, learning from data instead of pictures of cats. Deep learning is a branch of machine learning, which is itself a subset of artificial intelligence. But unlike traditional machine learning models, deep learning models are designed to automatically and adaptively learn from data, much like how we learn from experiences. Deep learning involves the construction of artificial neural networks. Think of these as a simplified, virtual version of our brain's network of neurons. These networks are deep because they have multiple layers, each performing a specific function. Imagine the process of recognizing a friend's face. The first layer of neurons might recognize the basic shapes: the oval of a face, the rectangles of the eyes. The next layer might recognize more complex features, like the color of the eyes or the shape of the nose, and so on until the final layer recognizes your friend's face as a whole. The same principle applies to other applications of deep learning. Voice assistants, for example, use deep learning to understand our commands. The first layer of the network might pick up the basic sounds. The next could recognize words, then phrases, and finally, the entire command. Each time a deep learning model processes data, it adjusts its internal parameters a little bit in an attempt to improve its predictions. This process of constant learning and adaptation is what makes deep learning so powerful. Yet despite its complexity, the essence of deep learning is simple. It's about learning from data. Whether it's recognizing a cat, a face, or understanding a spoken command, deep learning models are designed to learn and improve over time, much like humans do. Thus, deep learning is like a virtual brain, learning from data just like we learn from experiences. Like all superheroes, deep learning also has its strengths and weaknesses. Let's dive into the world of deep learning, a subset of machine learning that uses artificial neural networks to solve complex problems. It's like a digital brain, constructing deep neural networks with multiple layers to learn hierarchical representations of data. One of the most significant advantages of deep learning is its ability to handle large and complex datasets. Imagine being in a library with millions of books, and you're tasked with finding specific information in all of them. That's the kind of heavy lifting deep learning is capable of. It can sift through vast amounts of data, identify patterns, and extract valuable insights. Another powerful ability of deep learning is automatic feature extraction. This means it can learn important features from the data all by itself, without any human intervention. Picture a toddler learning to recognize shapes and colors. They don't need anyone to point out what's important. They learn by observing. That's exactly what deep learning does, but on a much larger scale. However, like every hero, deep learning also has its kryptonite. One of the major challenges is the high computational cost. Deep learning algorithms require powerful machines and a lot of time to process the data. It's like trying to cook a feast for 1,000 people in a home kitchen. You might manage, but it would take a significant amount of time and resources. Another limitation is the need for extensive data. To train a deep learning model effectively, you need a lot of data. It's like learning a new language. The more words and phrases you know, the better you can communicate. In the same way, deep learning needs a lot of examples to learn effectively. So, while deep learning is a powerful tool, it's not without its kryptonite. But remember, every limitation is an opportunity for innovation. As we continue to refine and advance these technologies, who knows what incredible feats of digital strength we'll witness next. Deep learning isn't just theoretical, it's all around us, making our lives easier in ways we may not even realize. If you've ever asked Siri a question, you've interacted with deep learning. The ability to understand and respond to your queries accurately is a result of complex algorithms and multiple layers of artificial neural networks. But it's not just voice assistants. If you ever used Google Translate to understand a foreign text, you've used deep learning. This technology uses deep learning to process and translate languages, making it easier for us to communicate and understand each other. And let's not forget about image recognition. Every time you unlock your smartphone with your face, it's deep learning at work. The technology is able to identify and verify your face from thousands, if not millions of others, thanks to the layered architecture of deep learning. These examples are just the tip of the iceberg. Deep learning is also used in medical imaging to detect diseases, in self-driving cars to navigate roads, and in e-commerce to recommend products based on our browsing and buying patterns. It's also used in natural language processing, enabling our devices to understand and respond to our spoken commands. The potential of deep learning stretches far beyond these applications. Its ability to learn from large and complex datasets opens up a world of possibilities. As we generate more data, deep learning will continue to evolve, leading to even more innovative applications. We might not always realize it, but deep learning is deeply embedded in our daily lives. It's in the devices we use, the services we access, and the conveniences we enjoy. It's an invisible force, quietly revolutionizing the way we live and work. From our smartphones to our homes, deep learning is quietly revolutionizing our world. So, what does the future hold for deep learning? Well, the possibilities are as vast as our imaginations. As we step into tomorrow, deep learning emerges as a beacon of opportunity. It's not just a technological revolution, but a tool with the potential to reshape our world and solve some of our most pressing problems. Consider healthcare, a field ripe for innovation. With deep learning, we can predict diseases before they manifest, customize treatment plans to an individual's genetic makeup, and even create intelligent prosthetics that respond to neural signals. Just imagine a world where ailments are not just managed, but predicted and prevented. That's the potent promise of deep learning in healthcare. The transportation sector is no different. Autonomous vehicles are becoming an exciting reality with deep learning at the helm. By interpreting vast amounts of data from sensors and cameras, these smart machines can navigate complex environments, adjust to changing conditions, and make split-second decisions, all with minimal human intervention. Deep learning could transform our roads, making them safer and more efficient. But the scope of deep learning extends beyond these industries. It's a key player in fields as diverse as climate science, where it can predict extreme weather patterns, and agriculture, where it can optimize crop yields and reduce waste. Moreover, as our computational capabilities grow, so too will our ability to handle larger, more complex datasets. This will allow deep learning algorithms to become even more accurate and sophisticated, opening up new realms of possibility. But let's not lose sight of the challenges. Deep learning is a powerful tool, but it's not a magic wand. It requires vast amounts of data and computational resources, and there are important questions around privacy and security. We'll need to navigate these hurdles with care as we move forward. Yet despite these challenges, the future of deep learning is undeniably bright. It's a journey of discovery as we continue to unravel the mysteries of artificial intelligence and push the boundaries of what's possible. As we continue to harness the power of deep learning, who knows what miracles we might achieve? The future is bright, and it's powered by AI,